morning everyone. In this video, let us see how the hydraulic circuit has been traced in the fluid power. So now before going into the session, the strainer which is used to filter that fluid is mixed type of displacement pump, and it's a unidirectional pump and it is rotating in one direction. It is driven by electric motor as shown over here. So here the single acting cylinder, and the cylinder, the fluid that pushes the cylinder which moves from the left to right and the right to left. This linear motion is being executed through the pump, and then the particular fluid is sensed by this relief valve. If the pressure is executed in as compromised so that in the normally closed position, and we have been shown over here, and if the pressure exceeds a certain design value, then it will open, and we can say that this arrow that allows the position of the particular DCV, so that the position will be like this. Again the liquid will be flowing through the pump over there, and it will be coming over here, and then it's going directly again go back, and further operation will be performed if the pressure is executed correct, if it exceeds the design pressure. Then this pressure gauge which indicates the pressure, and it is normally a shut-off valve. Now let's see how this four-way DCV works, and it is one of the most important part in the hydraulic system, in which it shows a four-way. So we can see PR12. P stands for the pump port, R stands for the receiver port, 1 is the inlet of the cylinder, and 2 is the outlet of the cylinder. And so here the central position is shown over here, which is been blocked. The fluid is allowed to from the pump is entered, and it is drained through the port, and no way the action will happen when in this position, and no operation will be performed. In simple, we have to say. So now we can see over here how the lever type DCV is being operated. When I push the lever, the DCV will get to the left envelope, and so that we can say that PR will be transferred over here, and similarly 1 and 2 will be transferred over here. At the present, the fluid will be pumped through the port P, and it is allowed to move to the port 1, and then it enters through the restricting opening and allows the fluid to enter into the cylinder. As the force exits, the piston moves from the left to right. Meanwhile, the fluid over there will be drained to the port 2, and it moves towards the R, and it reaches the tank. When we operate the lever or release the push, we get the right envelope. We assume that the particular position is present over here. So the P becomes over there, and R will come over there, and 1 will be in the left portion of the third way, and the 2 will be operated over there. And so in this way, the 4-way and 3-position valve works. And there are 3 positions. The central one is the blocked position, as I said earlier, and it is very close to envelope. And this lever operator spring enhances the return stroke of the DC. Another important component in the hydraulic circuit is particularly the flow control valve. In the integrated section, the check valve is a function allows fluid only in one direction. Now, when the fluid, for example, in a particular system, there is no free flow condition and no flow condition for the check valve, so the liquid cannot flow, and so it is compressed. Now you see how the animation works. In the reservoir, the pump is being pumped, and it is moved to the port P, and from the port P it enters the head of the cylinder. As a result of the high pressure buildup, the plunger will move from the left to right direction. Meanwhile, the fluid over the port 4 will drain through the port 2 and reaches the R port, and it is drained back to the tank. So in this way, we can choose the particular flow of fluid in the circuit diagram. So meanwhile, they can also place the circuit shuttle valve over the head portion of the actuator. So it can be shown that it has no flow, so the piston will slowly move backward. So now we can see the right envelope. We are activating the DC. Now the pump is being drained, and because of the cross arrow, the pump will move towards the port 2, and it enters into the tail portion of the actuator. As a result of which, the piston will move in the backward direction. Meanwhile, the fluid in the head portion of the cylinder will be reaching the port 2 and port P, and it reaches the R and drain back to the tank. Since here I have placed the check valve, and the check valve will allow the flow control in one direction. So the free flow of the fluid from the port is permitted. In this way, the circuit diagrams will work. I hope this video has given you a clarity about how the DCB works and